Cytochrome P450 enzyme, a mixed function oxidase system, is found in most organs, especially in liver, as we mentioned before, and tissues where metabolic processes occurs. Also has the ability of metabolizing unlimited number of diverse substrates by a variety of oxidative transformations. And this versatility, tanawwu', is believed to be attributable to the number one, substrate non-specificity of cytochrome P450, as well as number two, to the presence of multiple forms of the enzyme, That means the cytochrome has the ability to oxidize or metabolize non-specific or different types of substrates. And this is due to the presence of multiple forms of the enzyme, especially of the protein substituent or constituent of the enzyme. Generally, lipophilic xenobiotics or drugs are generally good substrates for this enzyme system, and is believed as due to its state in-house lipoidal environment, and this has the ability of the enzyme to oxidize multiple numbers of molecules, and in this case the enzyme is a heme protein enzyme. Cytochrome P450 enzyme is a heme protein enzyme in which the heme portion is an iron. It is an iron containing porphyrin called protoporphyrin 9. While the protein portion is called apoprotein, portion. As shown in this figure, it was indicated that apoprotein portion is found in various cytochrome P450 enzymes appear to differ from one another in their tertiary three-dimensional structure, and this owing to differences in amino acid sequence or the makeup of polypeptide chain. Therefore, this is attributable to the multiple forms of the enzyme and unlimited number of compounds to be metabolized by the same enzyme. Since the apoprotein portion is important in substrate binding and catalytic transfer of activated oxygen, as we see it here, this represents the substrate which is in contact with the apoprotein portion, and in this case most of the lipophilic drugs will bind the lipophilic property of the protein, and in this case the activated oxygen of the enzyme will be near the substrate to be oxidized to give the product. نيجي إلى الفirst group of organic compounds which are oxidized or suffers this type of oxidative reactions are oxidation of aromatic moieties. The first step is the formation of iron oxide intermediate through epoxidation. Iron oxide is electrophilic and chemically reactive owing to the strained three-membered epoxide ring as toxic and will be it is a toxic and could be detoxified by either of the following reactions. First, either through spontaneous rearrangement to arenol, either through spontaneous rearrangement to arenol through NIH shift, or detoxified through second process, which is enzymatic hydration to transdihydrodiols by reaction with water molecule to give transdihydrodiols, or through the third process of detoxification by conjugation with the glutathione. Otherwise, if not detoxified by any one of these three previous mentioned processes, it will give a toxicity to the body. Will happen in this case through covalent binding with the nucleophilic groups present in proteins, DNA, or RNA nucleic acids to cause their modification, and in turn toxicity will occur. Quantitatively, the most important detoxifying or detoxification process will occur of iron oxide is the rearrangement rapidly and spontaneously to arenol. The most important one will occur through spontaneous rearrangement to arenol. Most phenolic metabolites formed from or aromatic oxidation undergo further conversion to polar and water soluble glucuronide or sulfate conjugation through phase 2. Mostly through phase 2 will be happen with the arenol or alcoholic compounds, aromatic phenolic compounds, conjugation with the glucuronic acid or sulfate to be easily eliminated with urine. Examples in this case, for example, propranolol اللي هو adrenergic agents, beta-adrenergic agents, which is used in the treatment of hypertension, and here hydroxylation occurs at this 4 position, and here you see that the arrow. وهذا ما يعني بالامتحان من أجيب لكم سؤال مو تجون ترسموا لي arrow، وإنما هذا حتى لا نعيد رسم الستراكشرال فورمولا، لكن فقط حتى نبين أنه الهيدروكسيليشن occurs at this position. Another example is phenobarbital اللي هو barbiturate in nature as sedative hypnotic compound, while hydroxylation occurs at this position. The third compound or drug which will be oxidized through arenol is phenytoin, which is greatly metabolized through arenol intermediate to give this the arenol give parahydroxyphenytoin, then by conjugation through phase 2 will give, for example, with the glucuronic acid to give beta-glucuronide. Another example is phenylbutazone, which acts as anti-inflammatory agent through its metabolite oxyphenylbutazone. Means that phenylbutazone acts as anti-inflammatory agent through the effect of oxyphenylbutazone or oxybutazone. This is the metabolite which gives the anti-inflammatory effect of phenylbutazone. The extent of microsomal hydroxylation of aromatic ring to give the arenol form is by the substituents attached to the ring. That means the nature of the substituents attached to the ring will affect at the extent of hydroxylation of the ring. In that, substituents activated the rings toward nucleophilic reactions, that means electron-rich rings, enhances the hydroxylation, whereas deactivated aromatic rings, that means when the deactivating groups are attached to the ring, like chlorine and R3 plus COO carboxyl SO2 NHR sulfonyl group, are generally show or resist to hydroxylation, because these last groups will deactivate the aromatic ring toward the arene or arenol formation. For example, clonidine is used as antihypertensive. It has two chlorine atoms attached at the aromatic ring, and also the aromatic ring attached to imine NH group. These are deactivating of the aromatic ring toward the hydroxylation, and because of this deactivation property by this deactivating group will cause for the clonidine to have a half-life about 20 hours. That means a long time, because of the slow metabolism by parahydroxylation and its O-glucuronide formation, which is the major metabolite of the clonidine of the. Another example about the deactivating effect of the substituents is in case of a propanseed in which the benzene ring of aromatic ring has two deactivating group, carboxyl and sulfonyl group. For this reason, arene oxide or arenol will not be formed, but metabolism occurs through glucuronic acid conjugation with the carboxyl group to give glucuronate and ester, and this propanseed is used as a uricosuric compound that increases the excretion of uric acid with the urine. The presence of more than one aromatic ring for a benzene ring will show hydroxylation occurs at one aromatic ring more than the other. For example, in case of diazepam, which has two aromatic rings, benzene ring 1 is deactivated by chlorine, while the other is remaining not affected its activation. Therefore, in this case, the hydroxylation will occur at the ring which is not affected by deactivating groups, such as in this case. Therefore, hydroxylation occurs at 4' position to give 4' hydroxy diazepam, which is a tranquilizer. Another example about the presence of two different aromatic ring is a chloropromazine, and in this case, due to the presence of chlorine at this aromatic ring, hydroxylation will occur at carbon atom number 7 to give 7-hydroxychloropromazine. In certain hydrophobic compounds which are found or used as pollutants are the compounds which has a multiple number of aromatic rings and multiple numbers of deactivating groups اللي هم chlorine groups, such as in case of polychlorinated biphenyls and TCDD اللي يمتلك على chlorine atoms at position 2 and 3, 7 and 8, and these are remaining for a long time inside the body for several years without the hydroxylation product formation. We mentioned that arenol formation occurs through NIH shift mechanism, and this is a proved by taking this compound اللي هو 4-deuterioanizole deuterated compound, deuterated aromatic ring. This will show this iron oxide formation. Then by this will give the zwitterion species, and by the effect of 1,2-deuteride H shift, which represents the NIH shift, will shift the deuteride to the position number 3. So we're starting with the deuterium at position number 4, then the product will be the deuterium at position number 3, that is to give 3-deuterio-4-hydroxyanizole. 3-deuterio-4-hydroxyanizole. Also, to a limited extent, some of the deuterium might be lost to give this final product without the NIH shift. This is a limited extent of loss of deuterium ion. Second way of detoxification of iron oxide is through enzymatic hydration by nucleophilic attack of water to yield trans-dihydrodiol metabolized by the effect of enzyme epoxide hydrase. By epoxide hydrase in the presence of water molecule will give a trans-dihydrodiol. This occurs by the effect of the enzyme epoxide hydrase. Some drugs, major amounts of them are metabolized through this way. As example, phenytoin. Phenytoin will give iron oxide, then to a minor will give the dihydrodiol, addition of water molecule by the effect of epoxide hydrase, and as I mentioned before, that is the major will be through parahydroxyphenytoin, but the minor will be through the second way of detoxification through dihydrodiol. Then this dihydrodiol either conjugates with the glucuronic acid through phase 2 or goes to a minor extent by the enzymatic oxidation to give catechol moiety, There are two types of inhibitors of epoxide hydrases enzyme which are responsible about the dihydrodiol formation. These inhibitors of the enzyme are cyclohexene and 1,1,1-trichloropropene 2,3-oxide. These are used as inhibitors to the epoxide hydrase by reaction with the epoxide hydrase, preventing the enzyme to act at the arene oxide. Third way of detoxification of arene oxide is its enzymatic conjugation with the glutathione. And as I told you that the glutathione in this case binds to protect the body against the harmful compounds. And this occurs through enzymatic effect by conjugation of glutathione through sulfhydryl group, which acts as a nucleophilic group to yield the trans-glutathione adduct to give the trans-glutathione adduct, which in turn through a series of reactions yield the premercapturic acid. Through a series of steps of compounds give premercapturic acid, then finally, this is the premercapturic acid, then finally to give the last product, which is the mercapturic acid, through loss of water molecule from premercapturic acid intermediate. ومثل ما نعرف الجلوتاثيون شنو هو ترايبيبتايز اللي يتكون من الجلوتاميك acid, cysteine and the glycine, and through a series of steps will cause, at the first step will lose the gamma glutamyl or glutamic acid. Second step is loss of glycine, remaining the cysteine within the premercapturic acid, then enter within the mercapturic acid as a tripeptide, the glutathione. Some polycyclic aromatic hydrocarbons were found to be carcinogenic. For example, benzapyrene. Benzapyrene acts as carcinogenic compound to cause a cancer, and this occurs through metabolism through a number of dihydrodiol metabolites, and evidence for the arene oxide intermediate formation. And in the intermediate that is highly reactive for covalently binding of DNA and in turn causes carcinogenicity, and this occurs through these steps. Benzapyrene through arene oxide gives 7,8 oxide, then this will through epoxide hydrase to give dihydrodiol, 7,8 transdihydrodiol. Then this dihydrodiol suffers a second step of epoxidation to give epoxide form, and in the presence of DNA will give the final injury, final harmful effect, which is the carcinogenic effect to bind the deoxyribose of the DNA Also, another example is carcinogenic activity of 7,12-dimethylbenzoanthracene. Benzoanthracene. This another carcinogenic compound اللي هو 7,12-dimethylbenzoanthracene, also through epoxide formation to give 5,6 oxide, and in the presence of RNA through 2' carbon atom hydroxyl group, 2' hydroxyl group of ribose of a guanosine residue of RNA to yield the adduct, and here attachment of the RNA will either at position number 5 to give this isomer, or through position number 6 to give another isomer, position number 6.